Okay, in this video we're going to introduce simplifying radical expressions. In particular, we're going to look at writing radicals, it's not easy to say, as rational exponents and vice versa. So try saying this objective 3 times very fast, and let me know how you do. So first, a little bit of vocab here. First up is a radicand, which for something, a term inside of a root, whether it be a square root, cube root, fourth root, etc., for any term inside of a root, that term is referred to as a radicand. So if we have the nth root of a represents the radicand. So we could have a square root, a cube root, fourth root, etc. So n represents a positive integer, usually 2 or higher. So let's take a look at the cube root of 27 squared and figure out what exactly this is. So if we first look inside the parentheses and look at what the cube root of 27 is, the cube root of 27 is 3, because 3 times 3 times 3, when we multiply 3 by itself 3 times, we get 27. Like the cube root of 8 is 2, because when you take 2 times 2 times 2, you get 8. So when we square that answer of 3, because cube root of 27 is 3, when we square that, we get our final answer of 9. And so to put things visually, suppose the block below represents the value 27. And since we're taking the cube root, we can divide the large block, this large square here, or large rectangle rather, into 3 equal blocks where instead of just adding to get from one number to the next, we have to multiply by 3. So we'll start with 1, and 1 times 3 will give us 3. 3 times 3 will give us 9, and then 9 times 3 is 27. So we have 3 equal blocks where to get from one to the next, we multiply by 3. So we can divide it up into 2 equal blocks for square roots, 3 for cube roots, 4 for fourth roots, etc. So whatever root we're taking, that's how many blocks we're going to divide it into. So in this case, 3. Now, if we look at what happens is we shade the block from the left up to our answer of 9. So we have our blocks, and we shade up to 9. So we started at 1 and shade or highlight all the way up to 9. Notice that in terms of the blocks themselves, 2 out of these 3 blocks are shaded. In this case, these 2 are shaded yellow, while this one is not. So this is actually a visual approach to the idea that the cube root of 27, when we square it, is actually 27 to the 2/3 power. The power represents what fraction of the total amount of blocks we have that end up shaded or highlighted. So in this case, we have for 27 here, we have 2 out of the 3 blocks shaded, and 27 to the 2/3 power is going to be what the shading ends up at. In this case, it ends up at 9. So in general, whatever root we take of something raised to a power, the fractional exponent of that is the radicand raised to the power over root. So for instance, the cube root of 27 being squared is 27 to the second power over the root of 3. So 27 to the power is 2, the root is 3. So example 1, write each of the following just using rational exponents. So we have the square root of 6. Now, this is 6 to the first power, and square root, the implied root, is 2. So we don't typically write the 2 there because we use it so much. We just all agreed that it represented a 2, so we wouldn't have to write it. So the power is 1, the root is 2, and our radicand is 6, so it's 6 to the 1/2 power. And going to be very valuable to keep in mind that square rooting something means you're raising it to the 1/2 power, and vice versa. Cube root of 8 is 8 to the 1/3 power. The power of 8 here is 1. The root is 3, so 8 to the 1/3 power, or 8 to the 1/3 power, which just so happens to equal 2. Part C, we have the fourth root of x cubed. So it's the power is 3, the root is 4, the radicand is x. We have x to the 3/4 power. All right, example 2, we're going to work backwards. We're going to write each of these in radical form. So 5 to the 1/2 power. So the power is 1, the root is 2, or square root. So it's the square root of 5 to the first power, or just square root of 5. Part B, negative 9 to the 5/3 power. The power is 5, the root is 3, so the cube root of negative 9 to the 5th power. And part C, we have x to the negative 1/3 power. The root is 3. The power of x is negative 1. So the cube root of x to the negative first power, or if we want to write this using positive exponents, it's 1 over x for x to the negative first power. So we'd have the cube root of 1 over x. So either one of these would be acceptable. All right, that about does it for this video. Thank you for watching. I'll see you next time.